Welcome to Scale Up University. Welcome to the course that is probability for machine learning. So in this course, we are basically learning probability for machine learning. So this is the lecture number 2 of module 1. And in this lecture, we will be discussing probability as a measure of belief and likelihood. So in the last lecture, we saw the importance of uncertainty in machine learning. We saw that uncertainty is something which is default in machine learning and in artificial intelligence, because the outcome of a AI model or the outcome of a machine learning model is always probabilistic. It will always be uncertain. It will have a chance associated with it. It will have a confidence level associated with it. The outcome cannot be certain. The outcome is uncertain. For example, if we talk about email, like spam email classifier. Now, given an email, it can say that okay, this email is a spam, but it there will be uncertainty associated with it. It will claim it to be a spam email with certain confidence level, like 70% chance is there that the email is spam. 30% chance is there that the email is not a spam. So machine learning, like whatever machine learning model you take, the outcome is always uncertain. So that all we discussed in great detail in the last lecture, lecture 1 of module 1. In this lecture, we will be basically quantifying the uncertainty. We will be measuring the uncertainty. We will see how do we measure uncertainty. That is the main agenda of this lecture. So in this lecture, we will be formally introducing probability as a measure of belief and likelihood. So what all topics we will discuss? So first we will look at what exactly is probability. What is probability? Then we will look at the meanings of events and outcomes. What do we mean by events? What do we mean by outcomes? Then we will talk about calculating probability using frequency. Then range and properties of probability. Some interesting properties of probability we will see. We'll look into it. Then sum of probabilities, some rules we will look at, like the sum of probability has to be 1. Then equal likelihood assumption we will talk about. And at the end, we will discuss notation and representation. Some notations and representation we will look at. So these will be the topics we will be looking at in this lecture one by one. So this is the module 1, what is probability, and lecture 2, probability as a measure of belief and likelihood. And we will straight away start with the first topic of this lecture, that is what is probability. So if I talk about the core definition of probability, so probability is basically a numerical measure that quantifies uncertainty. So probability basically tells us how likely something is. Probability tells us how strongly we believe it will occur, and probability tells us how often we expect it to happen in the long run. So basically in probability, we will be quantifying these statements, like how likely something is. So there will be a numerical measure. How strongly we believe it will occur, there will be a numerical measure. We'll be quantifying it. So the quantification of uncertainty is what is probability is. How often we expect it to happen in the long run. Now, one very important thing you should know, because whenever we talk about probability, we think that we are doing some guess. But very important point, probability is not a guess. Rather, it is a number between 0 and 1 that carries meaning. Probability is not a guess. It's a mathematical science. It's the science of measuring uncertainty. It's the science of quantifying uncertainty. It's not a guess. This is very important. Now, if we talk about what probability quantifies, so probability quantifies likelihood. That is, likelihood means how plausible an outcome is given what we know. So basically, see, what we know is the prior knowledge. So here, what we know is the prior knowledge, which we already have. And likelihood means based on our prior knowledge or based on our belief, how plausible an outcome is based on our prior knowledge. That is the likelihood. We will discuss it in great detail when we will be discussing Bayesian inference, Bayesian probability, conditional probability. There, this will make more sense to you, likelihood. But now, like, it's very clear to you that what is likelihood? Likelihood means based on the information we already have, based on the knowledge we have, how plausible an outcome is. That is the likelihood. It's like a conditional probability. Then we have something called as belief. So belief means how confident we are based on evidence. So that is the belief. So how confident we are based on evidence. So with probability, we can quantify likelihood, we can quantify belief, and we can even quantify expectations of occurrences. And what is this expectation of an occurrence? How often we expect an event to happen over time. So here expectation of occurrence is like more of like frequency. We will be calculating the frequency, like how often we expect an event to happen over time, like over a period of time, how many times that particular event might occur. So it is like a frequency test probability, wherein we will be dealing with frequencies. But when we talk about likelihood, we talk about belief. It is more of like conditional probability, wherein we are basically like we have some evidence, and based on evidence, how confident we are. Confidence level we will measure based on a given evidence, like some event occurred, and that is the evidence. So given that event occurred, what is the probability that this event will occur? Like conditional probability. So with probability, we can quantify likelihood, we can quantify belief, we can quantify expectation of occurrence. Like how often we expect an event to happen over time. If we look at the example of email spam prediction, now the output of this email spam prediction is something like this. It is probability of spam, probability of a spam email, and let us suppose if it is 0.87. So basically we quantified the spam because we know that the output of a machine learning model is always uncertain, it is always a probability. So email spam prediction is a machine learning model, and the output of it, like we give it a email, and it is giving us the probability of that email to be a spam is 0.87. So here this 0.87, what it is telling, it's telling that there is an 87% chance the given email is spam. So whatever email we provided to the model, there is a 87% chance that that email is spam. So we are quantifying the chance because here 87% chance. So with this quantification we are able to do because of the probability. Okay, now we'll look at the next topic of this lecture, that is events and outcomes. So what is an event? So an event is a specific outcome of an uncertain process. Now this is very important actually, this uncertain process, because whenever we talk about event, whenever we talk about probability, we are talking about uncertain process. And what is uncertain process? The process wherein the outcome is not fixed, because in certain process, definitely if that process occurred, the outcome is fixed. But in uncertain process, it can have multiple outcomes. For example, if I roll a dice, rolling of dice, now here 6 possible outcomes are there. Like because when you roll a dice, either you can get 1, you can get 2, you can get 3, you can get 4, you can get 5, you can get 6. So there is no certainty is there. we cannot say with certainty that, okay, if you roll a dice, you will get 3. You might get 2 also, you might get 4 also. So uncertain. So it's an uncertain process, rolling of dice. Picking a card from a deck of cards. Now, basically, this is an uncertain process because from a deck of cards, whatever card you will pick, I cannot say with certainty that okay, this is the card you will pick. You can pick any card. So it's an uncertain process. So there are many uncertain processes which we deal with in our daily life. In machine learning, there are so many uncertainties there. So what is an event? An event is a specific outcome of an uncertain process. Okay, like you rolled a dice, you got 2. So that's an event because 2 is a specific outcome. Now, the interestingly, we can assign probabilities to these specific outcomes. Like what's the probability of getting 1? Because outcome is uncertain, so there is a chance associated with the outcome. There is a probability associated with the outcome. So we can associate probability with the all the possible outcomes. And how we can associate probability, all that we will learn very soon. But now it's very clear that what is an event? An event is a specific outcome of an uncertain process, because in uncertain process the outcome is not fixed. We have many options for the outcome. So those are like possible outcomes, and from those possible outcomes, any one outcome will appear. Now, one more very interesting thing you should know about event. An event is not isolated. It is the result of a process. For example, if I talk about weather systems, in weather systems, flood is an event. Because see, if I talk about weather system, now that weather systems can have so many specific outcomes. Like when I talk about weather, flood can be there, heavy wind can be there, storm can be there. Similarly, if I talk about human behavior, now human behavior is uncertain. It's an uncertain process, and out of so many outcomes, one of the outcome is purchase. Like he can purchase some product. If I talk about a process like network activity, now this network activity, it's a process, and that process will involve so many outcomes, and one of the outcome will be the fraud, because that possibility is there. Now these outcomes, these specific outcomes, we can associate probabilities to them. Like okay, in the weather system, what is the probability of getting the flood? What is the probability that a particular customer will purchase a product? What is the probability of a fraudulent activity, fraudulent network activity? So we can associate probabilities with them. Probabilities can be associated. Now, if we look at one real world example related to machine learning, that is customer price prediction. Sorry, customer purchase prediction. Customer purchase prediction, wherein we are interested to know the event is customer purchases product in next 7 days. So this is the event we are interested in. So we have to do a prediction that like customer purchases product in the next 7 days. Now this event, it depends on many of the attributes or the features of the customer, like his income of the customer, his past behavior, shopping habits and all that, seasonality, pricing, random personal decisions. So these are some of the features which will influence the event. So this is very, very interesting thing we are discussing. That is what is the main concept of machine learning. So here the event we are interested in is customer purchases product in the next 7 days, and we have to calculate the probability of occurrence of this event because it is a specific outcome. And what's the outcome? Customer will purchase a product in the next 7 days. Now this event is influenced. This event is not isolated, but it is the result of a process. And when I say it is the result of a process, I say that this event is influenced by these many features, like the income. Income will influence the purchasing decision by the customer, the past behavior, seasonality, pricing, random personal decisions. All these will influence the event. And our machine learning model, what it will do? It will calculate P of purchase, that is the probability of purchase. And let us suppose it is 0.32. So here we can say that machine learning, it predicts event probabilities, because the outcome, that is 0.32, is the event probability, means probability of occurrence of the event. And interestingly, event is not isolated. This is a very important statement. Event is not isolated, but it is a result of a process. And in this particular example, customer purchase prediction, this event is influenced by these many features that will influence this probability of purchase. So ML predicts event probabilities, not deterministic outcomes. So machine learning predicts event probabilities and not deterministic outcomes. Okay, so now we will look into the next topic of this lecture, that is calculating probability using frequency. So basically now we will learn how to calculate probability using frequency. So the idea is that when we have historical data about the events, that is the specific outcomes of a process, of an uncertain process, probability can be estimated as probability is equal to occurrences divided by occurrences plus non-occurrences. Or in easy words, you can say that favorable events or favorable outcomes upon total outcomes. So this is what is probability is. This is how we can measure it. And this is basically called as empirical probability. Now for this empirical probability to work, for this formula to work, some conditions we should be we should take into consideration. So for this empirical probability to work, we should have representative historical data, because let us suppose we conducted any experiment, we should have data now, then only we'll be able to calculate probability, because here we are talking about total outcomes and in the numerator we have favorable outcomes. For example, let us suppose I throw the dice. So if I throw the dice, so total number of possible outcomes will be 6. And let us suppose I want to calculate the probability of getting 3. So the favorable outcome will be 1, that is 3, and total outcome is 6. So 1 by 6 will be the probability of getting a 3. So we should have historical data. And interestingly, this representative historical data, it will play a role in observing frequencies. Because with this historical data, we can observe frequencies. We can even learn patterns. And one more very interesting thing, in this empirical probabilities, events can be repeatable. What it means is that when I perform the same experiment multiple times, when I perform the same experiment multiple times, same event can occur. So events are repeatable. And one more very interesting and important point to be considered is the conditions of experiment should be stable. The conditions of experiment should be stable. Now in empirical probability, we are just telling or like calculating the probability based on the historical data. And one very important point to be noted, we are not commenting anything about the future. Like in empirical probability, we are not predicting future, because whatever probability we are calculating, that is based on the historical data representation. So it is giving insights about the historical data, and we are not predicting future when we are talking about empirical probability. One interesting example we can look into, that is click-through rates, CTR. So let us suppose we have some data, like we conducted an experiment, and there we saw that an ad was displayed 10,000 times and it was clicked 300 times. So if I want to calculate the probability of click, it will be occurrences, that is the clicks, that is 300, divided by occurrences plus non-occurrences. So occurrences is 300 and non-occurrences is 9,700, because 300 times it was clicked, 9,700 times it was not clicked. So it will give you 0.03. So this is the probability of clicking the ad. So in this way, we can calculate empirical probability. Now, one very important point, this empirical probability, as we already saw, it is basically based on the historical data, like we conducted an experiment, and based on the data of that, we got the probability. Now, this probability is conveying something very interesting. So this probability is based on frequencies in the data. So this empirical probability is based on the frequencies in the data. Okay, now we'll look at the next topic of this lecture, that is range and properties of probability. Range and properties of probability. Now if I talk about valid probability range, so it is between 0 and 1. So always remember, probabilities can never be negative, probabilities can never be greater than 1. The value of a probability has to be between 0 and 1, including 0 and 1. So the number between 0 and 1 is what the probability can be, and it is basically, it represents degrees of belief. So if the probability is 0, it implies impossible. Like probability of occurrence of an event is 0. It means that event will not occur at all. It's impossible for an event, for that event to occur. And if the probability is 1, it implies certain, because probability 1 means 100% surety that event will occur. It's certain that that event will occur. So now it's very clear to us that if I talk about valid probability range, probability can be 0, it means impossible. Probability can be 1, it means certain. And probability can take a number between 0 and 1, including 0 and 1. It cannot be a negative number, it cannot be a number greater than 1. So that is the valid probability range we are talking about. So these are the values probability can take. Now in this range, probability can be 0.1 also. Now 0.1, what it means is there is a chance of occurrence of event, but it is highly unlikely, because very less chance. So we call it unlikely. Probability can be 0.5, and 0.5 is like the midpoint, because 0 means impossible, 1 means 100% sure, and 0.1 is the midpoint. So here we cannot say anything uncertain. We cannot say anything about the event, whether it will occur or not, whether it is likely or not. And 0.9 means the event is highly likely. There is a high chance of occurrence of event. So like this, we can interpret probability. Now, one very important thing you should know about probability. So we saw that it can take any number between 0 and 1. So probability is continuous. It can take any number between 0 to 1. It is continuous in nature. Now, if I take one example like loan default risk, this example, if I take, let us suppose the output of the model is probability of getting a default is 0.62. What it means? It means probability of loan default is 0.62. It means 62 out of 100 applicants or 100 similar customers. So 62 out of 100 similar customers may default the loan. So this is how we interpret the probability. So we can say that probability turns vague risk into measurable quantities, because now this 0.62, this number is telling us the complete story. Because if I tell that, okay, high risk, low chance, so these are vague words. What is the meaning of high risk? How I can measure high risk? But instead of telling high risk, if I give a number, like here, instead of 0.62, if it becomes 0.8, then there is a very high chance that the customer will default. Loan default risk will increase. And if this number will become 0.22, then there is a less chance that the customer may default. So these measurable quantities is giving us the clear picture, and that is what probability is all about. So now we looked into some very interesting concepts of probability, like the range and properties of probability. Okay, now we will look into the next topic of this lecture, that is sum of probabilities. Now there is a fundamental rule associated with probability, and this fundamental rule of probability, it says that the probabilities of all possible outcomes must sum to 1. So this is a very important property. It is like a fundamental rule of probability. What it is saying is that in an uncertain event, we have set of possible outcomes. Now the probabilities of all those possible outcomes, if I sum, it has to be 1. So this is the fundamental rule. The probabilities of all possible outcomes must sum to 1. For example, if I throw a dice, if I throw a dice, 6 possibilities are there. Either I will get 1, I'll get 2, 3, 4, 5 or 6. Now the probability of getting 1 is 1 by 6. Probability of getting 2 is also 1 by 6. So probably what I am doing is that these are the possible outcomes 1, 2, 3, 4, 5, 6. I am calculating the probability of getting that possible outcome. So it will be 1 by 6. Now I got the probabilities of all possible outcomes, and if I sum it, interestingly you will see that it will be 1. So that is the fundamental rule, or sum of probabilities rule. And this is like a universal rule. Any uncertain event you take, you identify the all the possible outcomes, you calculate its probabilities, and when you sum the probabilities of all the possible outcomes, you will get 1. You have to get 1. That's the fundamental rule of probability. Now this rule is basically very handy when it comes to machine learning. For example, in machine learning, let us suppose you are making a multi-class classification model. So in multi-class classification, we can associate multiple classes to an input. And if I talk about an image classification, so here this multi-class classification is basically, it will classify images. Now one very interesting thing I'll share with you. Let us suppose the possible outcomes, or the in multi-class classification, the classes are cat, dog, rabbit, other. Now what will happen is that, see, when you pass an image to this image classification model or multi-class classification model, it will associate probability, that it will say that, okay, this is the image. What is the probability of it being cat? What is the probability of that image to be cat? Let us suppose that is 0.4, which is predicted by the machine learning model. And what is the probability that the given image is a dog? Let us suppose it is 0.3. What is the probability that it is a rabbit? Let us suppose it's 0.2, and other will be 0.1. So what it will do is that in multi-class classification, whenever you pass an image, it will give the probabilities of for every class. It will give the probabilities for every class that, okay, this is the input image. What is the probability for this input image to be cat? What is the probability for this input image to be dog? What is the probability for this input image to be rabbit? What is the probability for this input image to be other? And interestingly, when you sum all this, it will always be one. It will always be one. It has to be one. So the fundamental rule. So the sum will be always one. So in deep learning, there is something called as softmax. So softmax layers enforce this rule automatically. So this is a very powerful rule. This is a fundamental rule, sum of probabilities, and we have to keep it in mind. So always remember, whenever you are dealing with an uncertain process where the event, like where the outcome, we don't know, we have set of possible outcomes. So the sum of probabilities of all the set of possible outcomes has to be one. That's the idea. Okay, now we'll look into the next topic of this lecture, that is equal likelihood assumption. Now let us see what is this equal likelihood assumption is. So first, let us understand what is the meaning of equal likelihood. So when outcomes are equally likely, now what is meant by that when outcomes are equally likely? It means probability of all possible outcomes will be same. I'll give you example, then it will make more it will give you more clarity. When I toss a fair coin, what will happen? When I toss a fair coin, either I will get head or I will get tail. Now what's the probability of getting head? 1 by 2. And what's the probability of getting tail? 1 by 2. So here probability of both the possible outcomes is same. So we say that equally likely. We say that outcomes are equally likely. Similarly, if I take one more example, if I roll a fair dice, when I roll a fair dice, what are the possible outcomes I can get? I can get 1, I can get 2, I can get 3, I can get 4, I can get 5, or I can get 6. Now, what's the probability of getting 1? 1 by 6, because favorable event is 1, total number of event is 6. Probability of getting 2 is 1 by 6. Probability of getting 3 is 1 by 6. Probability of getting 4 is 1 by 6. Probability of getting 5 is 1 by 6. Probability of getting 6 is 1 by 6. Now here, probabilities of all possible outcomes are same. We call it equally likely. So here, what I can say that each outcome has same probability. So equal likelihood assumption, now it's very clear to you what is the meaning of equal likelihood assumption. It means that whatever like uncertain process we are dealing with, it will generate some outcomes. Now the probability of all those outcomes has to be same. That is the assumption I'm talking about, equal likelihood assumption. And it is very important because when outcomes are equally likely, then the analysis will be unbiased. Because see, when the assumption breaks, when the equal likelihood assumption breaks, what will happen? Let us see. Actually, when your real world data, which we deal, when this real world data, it is biased. See, whenever the real world data is biased, definitely we cannot get equally likely, like equal likelihood, because when the data is biased, some of the outcomes will have high probabilities and some of the outcomes will have low probabilities. And unfortunately, real world data is biased. When the real world data is imbalanced and when the real world data has some sort of structure, in those scenarios, we cannot get equal likelihood. In these scenarios, whenever the real world data is biased, real world data is imbalanced, real world data has some sort of structure, there will be outcomes. There will be some outcomes which will be having larger probabilities. So equal likelihood assumption will not be followed. And unfortunately, equal likelihood is rare in machine learning. Now let us look at with an example, like machine learning example, let us consider. Why equal likelihood is rare in machine learning? Now let us suppose if we consider a fraud detection model. Now in this fraud detection, the training data, it is imbalanced. So here fraud percentage is 1%, like the training data, the samples it is containing, 1% of the sample is labeled as fraud. It has the features of fraud, and 99% is non-fraud. Now this real world data is highly biased, imbalanced. And now the problem is that because of this imbalanced, we cannot consider equal likelihood assumption. Because if we assume equal likelihood assumption, what equal likelihood assumption here means is that probability of getting a fraud sample is equal to the probability of getting a non-fraud sample. But that is not possible here because out of 100% sample, only 1% is fraud and 99% is non-fraud. So we have to be very careful. We have to be very careful. We cannot use equal likelihood assumption in machine learning because here the it is highly imbalanced, and very easily we can see that probability of getting a non-fraud sample is very high as compared to probability of getting a fraud sample. Okay, now we'll look at the last topic of this lecture, that is notation and representation. So basically we can represent probabilities in several ways. So if I talk about common probability representations, I can represent it as decimal, like 0.75. For example, I can represent the probability as fraction, like 3 by 4. I can represent the probability as percentage, like 75%. Now, all these are same. All are same, just different way of representing. All represent same belief. Now, in machine learning, if we look into the notation and representation, so if we talk about model output formats with regards to machine learning, so for logistic regression model, the output is always in the form of probability. When you are doing some sort of thresholding, then the output will be a decision because you are creating a decision boundary. And when we are dealing with some sort of dashboard, then the output format is some sort of percentages. Now here, one very interesting thing we can see is that different way of representation, and this representation, it just changes the presentation and not the meaning. Meaning is still preserved. So the idea is very clear. There are different ways of like notation and representation. Like we can represent probabilities in different ways. We can represent model output formats in different ways. So representation may change the presentation, but it will not alter the meaning. Meaning will be same. So finally, we completed this lecture. So in this lecture, basically you saw like how we can quantify uncertainty, how we can measure uncertainty using probability. And we got a feeling that why machine learning output probabilities. We saw how probabilities are computed. We saw the frequency, like empirical probability, which basically identifies the frequencies in the underlying historical representation of data. And we also saw how to interpret model confidence correctly. So we got some good understanding because we are like just building the foundations in this course on probability for machine learning. This was the second lecture. I hope you liked it. You got some good understanding of the concepts. So do subscribe to our YouTube channel for more such interesting lectures and courses. Do share it in your circle, share it with your friends, with your family, and you can like if you want to discuss anything with me, you can drop in a comment. And yeah, thanks for watching. Thanks for your time.